Good morning. Hope everyone's doing well. Hope everyone's healthy and happy and safe. Let's jump in. Today's goal, I can divide a unit fraction by a whole number. We've already practiced dividing a whole number by a unit fraction, so now we're switching it, and we're going to practice dividing a unit fraction by a whole number. And like we did before, we're not going to come right out and tell you how to do this. We're going to show you a bunch of examples and see if you can get there by yourself. See if you can figure out the mechanics involved based upon real life examples and making models. Here we go. Let's remember what grouping versus sharing is. Here's a pretty easy example, 12 divided by 4. We, of course, know that 12 divided by 4 is 3, because 3 times 4 is 12. Let's read these two examples and see that we understand the difference between sharing and grouping. Sally had 12 dog biscuits. She split them evenly among her 4 dogs. How many did each dog get? Well, we've got the 12 dog biscuits, and that's our dividend. She's splitting them up among 4 dogs. Those are groups, 4 groups. How much does each dog get? We don't know how many they each get. They'll get 3, so that's our answer, our quotient. That is a sharing problem. Now the grouping. Sally made 12 homemade dog treats. She tied bows around bundles of 4 for gifts. How many bundles can she make? Notice the question. It's saying how many bundles, how many groups can she make? We know they are groups of 4. So she put 4 together, tied them up, put another 4 together, tied them up, put the last 4 together and tied them up. She was able to make 3 groups. Since grouping problems answer how many groups, that is a grouping problem. Take a look here. Here's 2 more examples of sharing and grouping. I'm going to mix it up a little bit, though. Let's do this. Let's move this around a little bit. Whoops. Let's take a look and see which one's which. And I'm going to let you read them. And which one do you think is grouping? Which one do you think is sharing? Take a moment. Read those 2. Pause the video if you need to. Which one is which? Okay, pause if you need more time. Sally finds 8 quarters on the floor of her car. She decides to use them to buy $1 coffees at Cumby. How many coffees can she buy? Well, 8 quarters, and she's using them to buy $1 coffees. She's putting 4 quarters together to make $1. So her groups are 4 quarters. How many groups of 4 can she make? This is a grouping question because we didn't know how many groups she could make. So this must be sharing. Let's read and see if that makes sense. Sally found 8 quarters on the floor of her car. She gives them evenly to her 4 children. How many will each child get? That just sounds like sharing. Sharing quarters with kids is definitely sharing. What about this one? A half divided by 4. Well, imagine half of something, like a pizza, and 4 people are going to split it. Imagine you had a big party pizza, and the next day there's half of it left. Couldn't 4 people share what was left? That's pretty easy to imagine. But now imagine you're grouping, and you have half of something, like half a cookie, and you want to put them into groups of 4. Can you make groups of 4 out of half of a cookie? No, and it's not asking you to cut it up. That's not a grouping division problem like this. So this doesn't make any sense. So we need to call that impossible. Every time we have a fraction divided by a whole number, it is automatically a sharing problem. It's impossible to have a grouping problem that's a fraction divided by a whole number. Just like it's impossible to have a whole number divided by a fraction be sharing, because you can't share something among half a person, this is the opposite impossibility. So if you read a story problem and it sounds like it's sharing, it must be a fraction divided by a whole number. If it's the opposite, and you can't decide if it's fraction first or whole number first, If it's a grouping situation, it must be a whole number divided by a fraction. So keep that in mind as we look at some examples. Now I'm going to pause the video here and give everyone a chance to create this on a piece of scratch paper. You don't have to redraw the whole square, but let's remember one thing. The side of the square is one entire unit. So that means that one little piece of it is 1/4 of a unit. So we're going to do one of these together, then I'm going to let you pause the video and find the area of all of the other pieces. Let's find the area of C. C is 1/4 of a unit across the top and 2/4 of a unit vertically. So it's 1/4 times 2/4. Sorry, this is a little awkward, me writing with a mouse. So what is the answer to 1/4 times 2/4? We should be pretty adept at this by now. It comes out to be 2/16, which of course reduces, what does it reduce to? Go ahead. It reduces to 1/8. So 2/16, does that make sense? Well, if I did this, aren't there 16 squares in this whole thing, 4 by 4? And C is 2 of them. So that is 2/16. It's also 1/8. So I'm going to leave the 1/8 here for C. And now you can pause the video and find the area of the other sections. Pause for as long as it takes you. I'm going to wait a few seconds before I continue. Okay, pause if you need more time. Let's figure out section A. Section A is 2/4 by 4/4, or a half times 1/2. So that would come out to be a half. And doesn't that look like half of the whole square? How about B? B is 1/4 times 4/4, or 1/2. So that means the area of B is 1/4. And doesn't it look like this is 1/4 of the whole thing, because there would be 4 columns going up and down? How about D? D is 1/4 times 1/4. 1 times 1/4 would be 1/16. And we can see that if there are 16 squares, this is one of them. So that leaves E. Well, E looks like half of D, doesn't it? So if D is 1/16 and E is half of that, we would do 1/16 times 1/2. That's half of 1/16. Remember, in a multiple fraction times fraction, the multiplication symbol means of. So it's half of 1/16. Well, half of a 16th, 16 times 2, is 32. So it would be 1 out of 32 pieces. And if we cut each of these in half, we could see that there would be 2, 4, 6, 8, 16, all the way up to 32 of these half pieces. So now, let's put that to use. Imagine that Sally has half a pan of cornbread left. She lets her 4 dogs split it. How much of the whole pan will each dog get? Well, we're splitting the cornbread, and we're letting her dogs share it. She's got half a pan of cornbread, so we have half a pan, and it's being divided up among her 4 dogs. Let me draw what the half a pan of cornbread would look like. It would be half of it, like this. And yellow is appropriate, because cornbread is yellowish. And the 4 dogs are sharing it. So each dog would get one of these 4 pieces. So each dog would get one of these. That's what each dog would get. One dog would get that piece, another dog would get this piece, another dog would get this piece, and another dog would get this piece. So what does this come out to be? Well, that looks like 2/16, doesn't it? Each dog would get 2/16. But 2/16 reduces to 1/8. And I'm going to use the reduced fraction as the answer. So 1/2 divided by 4 equals 1/8. Well, what do you notice about what's going on here? When we did a whole number divided by a fraction, our answer was a whole number. But now we have a fraction divided by a whole number, and our answer is a fraction. We have a 2 and a 4 and an 8. The 1 and the 1 here seem the same. Maybe you're starting to figure this out already. Let's look at another example. Imagine there's a third of the pan of cornbread left, and she has 3 dogs. So this yellow is what's left in the pan, and now the 3 dogs are going to share it. So we would split it into 3 pieces. Now notice that I'm making my lines go all the way across, so I can read the whole pan, not just the piece that's left. So how many pieces are there left now? There's 9. Each dog would get 1 out of the 9 pieces. It could also look like this. If we split the third into 3 parts, we can see that each part is 1/9 of the whole pan. So 1/3 divided by 3 is 1/9. Well, hopefully you noticed that we started with a fraction and ended with a fraction. But how did we get a 9th? We have a 3, we have a 3. Let's try another one. Imagine there's a fourth of a pan of brownies left. Jake and his 3 brothers are going to share the fourth equally. What fraction of the pan of brownies will each of the 4 boys get? Well, I'm going to write the equation first here. We're not dividing the boys, we're dividing the brownies. So we're dividing a fourth of a pan of brownies among 4 boys. It is 4 boys because Jake and 3 brothers. But what does this look like? Let's take a look. It looks like this. Here's the 1/4 of the pan of brownies that was left. And these lines divide it among the 4 boys. They would each get 1 out of 16 pieces. So our answer is 1/16. Notice we have a fraction ending in a fraction. How did we get to the 16? I bet some of you are thinking we did 4 times 4 is 16. Our 1 as a numerator stayed 1 as a numerator over here. Starting to become a little more obvious. Try another one. Imagine a third of a pan of lemon bars. So we're going to be dividing up a third of a pan of lemon bars. Sarah and her 3 cousins. So that's 4 girls, not 3 girls. So we're dividing them up among 4 girls. They're going to split this pan equally. What fraction of the pan of lemon bars will they each get? Well, let's try it mechanically first this time. I know I have to end in a fraction because I'm starting with a fraction. So far, my numerators have all been 1. And it looks like we could multiply the denominator times the whole number for our new denominator. 3 times 4 is 12. So mechanically, I'm coming up with 1/12. Let's see if the model supports that. Well, take a look. Here's the 1/3 of the pan of lemon bars divided into 4 sections. So each girl gets 1 section. And that would be 1 out of 12 of the whole pan. It seems like this is how it's done. So let's apply this to a story. One day, Grandma was baking brownies. Her 2 children arrived just as she was cutting up the last pan and packing the brownies into boxes for the bake sale. Grandma said, "I've got to run to the store for a few minutes. There's half a pan of brownies left. Get out the milk and you can share the half pan between you." The children's eyes got wide at the thought of milk and half a pan of Grandma's best brownies. Sounds good. We'll take a moment and on a piece of paper, draw a model of this and write an equation that shows it. We have 2 grandchildren sharing half a pan of brownies. So write an equation that shows that and a model that shows that. Now pause the video while you do your work and then press play when you're ready. I'm going to continue. This is what the model looks like. Here's the pan of brownies. This left column was what was left. It was split in half because there's 2 kids sharing it. It was divided into 2 pieces. Each child would get 1 out of the 4 pieces. And look at fraction divided by whole number equals a fraction. 2 times 2 is 4. Here's another section of the story. Just as the children sat down to enjoy the brownies, notice the just as. That should tell you as a reader something's about to happen. There was a knock at the door. It was their cousin, Junior, from next door. Well, they couldn't leave him out, so they poured a glass of milk for him and redivided the half pan of brownies fair and square. So do it again. Draw a new model and write an equation that shows this situation. This time, there are 3 kids sharing the half pan of brownies. So what does this model look like? What is your equation? Pause here. Okay. Pause more if you need more time. This is what a half divided by 3 looks like. Here's the half pan of brownies, divided into 3 sections, 1 for each child. It now looks like the pan of brownies is divided into 6 sections, and each child gets 1 of those 6 sections. Mechanically, fraction divided by whole number equals a fraction. Numerator is 1. 2 times 3 is 6. Here's the last section of the story. Just as the children sat down again to enjoy the brownies, there was a knock at the door. It was Junior's little brother. Well, they couldn't leave him out, so they poured a glass of milk for him and redivided the half pan of brownies fair and square. Make a model and draw an equation for now 4 children sharing the brownies. Pause if you need to. Here's what it looks like. Here's the half pan of brownies divided into 4 sections. That makes the whole pan divided into 8 sections, and each kid would get 1 out of 8. We know our answer is going to be a fraction. Numerator of 1. 2 times 4 is 8. I think at this point you probably could have it. So what if there were 5 kids? 6 kids? What if there were 10 kids sharing this half pan of brownies? How much would they each get? Pause the video here and write down your answers for these 3. Okay? Pause if you need more time. How much would each of 5 kids get if they were sharing half? Well, my answer is a fraction. 2 times 5 is 10. Numerator of 1. They would each get 1/10 of the pan of brownies. How about 6 kids? 2 times 6 is 12. Numerator of 1. They would each get 1/12. What if there were 10 kids sharing the brownies? That would mean that the half was divided into 10 pieces. The half that was already eaten would also be divided into 10 pieces. That would mean 20 pieces total. And each kid gets 1 of those 20 pieces. Try these 3. Try 1/4 divided by 6, 1/3 divided by 5, and 1/7 divided by 8. You can draw a picture if that helps you, but you can also, at this point, probably do it just mechanically. Pause the video here to figure out your answers and write them down. Then we'll check. Okay, here we go. 1/4 divided by 6. Remember, start with a fraction. Divided by a whole number means we end with a fraction. And 4 times 6 is 24. The numerator stays the same, 1/24. 1/3 divided by 5, 1/15 is the answer. And 1/7 divided by 8 is 1/56, because 7 times 8 is 56. Let's compare that to the opposite, when we have a whole number divided by a fraction. When we have a whole number divided by a fraction, we know we're going to end with a whole number, not a fraction. And we multiply the whole number times the denominator and get 16. When we do a fraction first divided by a whole number second, our answer is going to be a fraction. Numerator of 1, and 4 times 4 is 16. Hopefully that's clear. We're going to include a cheat sheet with this lesson with demonstrations of this, so you can have that at your fingertips. And we're going to practice that more in the next video lesson, but we're also assigning a page from the student book that's review of different skills. All right, see you next time.